This is the part 2 of trigonometric ratios and identities. In part 1, we had solved two simple questions from Ambal Khanna IIT Mathematics book. In this part also we will solve another problem from the same book. So let's have a look. Question given is prove that root over of 1 minus sin a by root over of 1 plus sin a, the whole root, is equal to sec a minus tan a. Okay, going to the solution straightforward. We see that the two sides have square roots and right hand side does not have, and we need to equate them. So we need to try and remove square root from the left hand side. So we can do this by multiplying both numerator and denominator by the same value, so that they become squares and the square root goes off. Okay, let's see. We can either multiply both by 1 minus sin a or root over 1 minus sin a or root over 1 plus sin a, so that internally they will become 1 minus sin a whole square or 1 plus sin a whole square. This thing will root will go. So we need to choose between these two. Okay, that way one of them will become a perfect square and the second one will be of the form of 1 minus sin a into 1 plus sin a. One will become 1 minus sin a whole square or 1 plus sin a whole square. Other will be 1 minus sin a and 1 plus sin a, which is 1 minus sin square a, which is cos square a. That again becomes a perfect square. Hence both numerator and denominator will become a perfect squares. Okay, so but if we look at the right hand side, it is actually of the form sec a is 1 minus cos a and tan a is sin a by cos a. So cos a as denominator, the right hand side has cos a as denominator. So on the left hand side also we will try making denominator as cos a. So to do this we will need to multiply this by 1 minus sin a. So we multiply both numerator and denominator by root over 1 minus sin a, and we get root over of 1 minus sin a into 1 minus sin a divided by root over 1 plus sin a into 1 minus sin a. This is the term we have multiplied both numerator and denominator. Okay, so that is 1 minus sin a whole square divided by 1 minus sin square a, which is equal to 1 minus sin a the whole square, the root is always there, divided by cos a square, the root. 1 minus sin a whole square, 1 minus sin square becomes cos a, and then we get this as 1 minus sin a, because it was a whole square, it goes away. It was cos square a, root over cos square a, the root goes away, it's cos a, which is again equal to 1 minus cos a, just removing the just separating the both terms in the numerator. 1 minus cos 1 by cos a minus sin a by cos a, 1 by cos a divided minus sin a by cos a, which is actually equal to 1 minus cos a is equal to tan sec a and sin a by cos a is equal to tan a. So our left hand side is equal to right hand side, hence it's solved. So it's the trick is simple. Whenever you get such kind of problems, you just need to multiply both one numerator and denominator by a value which will allow you to remove the square root and try to see what's there in the right hand side. Try to multiply with the value so that it's easier for you to prove. Over here we saw that right hand side has cos as denominator, so we multiplied by root over 1 minus sin a. Even if we would have multiplied by say 1 plus sin a both side, above we would have got a cos, and numerator we would have got a 1 plus sin and cos a by 1 plus sin a. Then it would have been difficult for us to get sec a and tan a. We would have to do a lot of more things to get that. So better we saw that it's cos a is there in the right hand side in denominator, so we multiplied by 1 minus sin a both sides, root over 1 minus sin a to both numerator and denominator, and easily got our answer. Okay, thank you for listening to this problem. You can visit PowerMyEdu.flv